Hello, my name is Legonic, and I will be presenting the discussion part on and also how the MATLAB works. So from here we can see for this lab we're gonna have to declare two things first. One of which is this big N, and also the small n, which will be arranged. So the maximum for the n, in this case for the end, for the big N, we can make it as many as possible, but in this case we're just going to make it only 10. We're going to limit it until 10, and this n is going to be until 9 because of this n minus 1 from 0 until 9. Then since we're going to have to do the discrete function discrete Fourier transform for this all four according to the lab sheet. We're going to have to do the direct delta, and also for this, for the exponential 2 pi exponential to the power of exponential 2 pi j small n j divided by the big N, and also the last one would be the cos 2 pi n over n, the small n over big N. Then you're gonna have to, of course, because since we are required to do the discrete Fourier transform, therefore we're gonna use the DFT EQN, and then we're gonna put all of this and to each one of this, and also put the big N in it. Then after this, all the values for the discrete Fourier transform will be stored in the variables over here in the front here. So, and then in order to display all these values, all these discrete Fourier transform values into the graph form, we're gonna have to first stem it, and then the small n, put this one in, and also make sure that it is filled for the circle to make it more visible, where the point is more visible. Then to x label it the name of the x-axis, and also to y label it, and also the title. The same goes to the other four, but the name of this, the name of each one of this graph will be different, because each one of them is only responsible for whichever it is assigned to. So as for this figure 1, it's going to be for this, from this one. For the figure 2, it's going to take the discrete Fourier transform from this, and the third one would be from this, and the fourth one, which is the last one, will be taking the values from this one. Okay, next up we're going to talk about the inverse discrete Fourier transform. Same as the previous case, all we have to do is, because since we are just going to inverse the discrete Fourier transform, all we have to do is to IDFT EQN x DFT1, which is right over here, this one. All of this will be used again right over here. But in this case, since we are inverse it, we're going to converse it. So it's just like this IDF. We just have to add IDFT EQN, and then same thing again, the N. Then over here, since we're going to display them in the graph form, we're going to copy the same thing. Going to put a figure, going to put a stem, make it grid on, and put the title, the X label, and also the Y label. Then, but before this, we're gonna have to. After this, we're gonna have to we're gonna have to solve two tasks. One of which is to create a function for the DFT EQ and XN. So here it is, specifically made for the XN multiplied with the exponential negative 2 pi n j multiplied with k minus 1 over big N. Then here it ends here. And then for the second one, for the IDFT, we have this. The function declaring the name and also the variable, and then you're going to declare the parameter, obviously, for each function. We're going to have to declare first, supposedly to be k here. And then next up, for n is equivalent to 1 until the big N, which is also the 10. But in this case, it's actually the 9. And then this one is also for the same thing, except that this is actually for the this equation. I mean, the thing that is here, the thing that sorry, my mistake. Actually, this is not the same as this one, because this is for the another. This is the another equation, which is not the same at all with this. So this function is going to be, this function is actually for the inverse, just go for transform, which is for this. The xn is equivalent to 1 over n multiplied with sum, the mathematical expression, multiplied with the big S, and then multiply with the exponential negative 2 pi j multiplied with multiply with n minus 1, and also lastly with the k as well, and then you're gonna have to divide it with the big N.
For part 4.2 3b, we will write a MATLAB for functions b equals to IDFT matrix bracket with the n to return the n times n's inverse matrix. In this code, we will use the for loop to calculate the n by n IDFT matrix. Then for question 3c, we will compute a and b with the n equals to 5, which a is equal to DFT matrix and b is equal to the IDFT matrix, which we will replace with the conjugate DFT matrix n divided by the n. Then we will also compute the C matrix C, which is equal to b times a. Then we run the code to see what is the product. Then you can see at the command window, the DFT A is equal to this one. The IDFT matrix for B is equal to this one. And the product of C is equal to BA is for this one. Then we do the questions number 4, which we will compare the DFT EQN and the DFT matrix bracket with n by using the functions FFT. You can see that these are the questions for part 4.1, which the question number 1 is this one, question number 2 is this one, and the question number 3 is this one, and the last one is this one. Then we write the code by using the FFT functions. Then for the questions part 4.2, the 2a is this one, and the 2b is this one, and 2c is this one. We also use the functions of FFT. Then we run the code. You can see that for a, the larger a, b, c, and d is equal to this one, and the smaller a, b, c is equal to this one, which the answer is same as by using the DFT EQN and the DFT matrix n, because both of them are using the FFT to run the code. That's all from me. Thank you.
In part 4.2, question 1, the DFT is required to implement as a matrix vector product. An equation x equal to ax is considered. By using a MATLAB function, A equal to DFT matrix in bracket n that returns the n by n DFT matrix a loop system is written, which is a for loop for n and k. The line for k equal to 1 colon n means that everything is between this line, and n will be evaluated with k equals to every integer between 1 and n. While the line for n equal to 1 colon n means that function a in bracket k comma n equal to exponential in bracket minus j times 2 times pi times k minus 1 times n minus 1 over n will be evaluated with n equals to every integer between 1 and n. The values get from a in bracket k minus k colon common n would be stored into a, and the function will end at here. In part 4.2, question 2, the matrix A is used to compute the DFT of signals. At first, n equal to 10 is defined and the w is equal to exponential in bracket minus 2j times pi over n is defined, which is the Twitter factor or the primitive n root of unity. Then the matrix is initialized using a equal to zeros in bracket n, comma n, to precise a as prior to entering the after for loop. The function a in bracket j comma k equal to w in power in bracket j minus 1 times k minus 1 is evaluated and the values will be stored into a and the function n here. To compute Sn equal to delta n, this code x equal to in bracket 1 zeros in bracket 1 over 9 is defined, which means only value of Sn remains 1 and returns a 1 by 9 matrix of zeros. The answer will times with a and we will get a capital X, which we'll use in the plotting the magnitude. Then for B, we need to define the X in bracket n equal to 1. First, we define x2 equal to 1 in bracket 1, comma 10, which means it will return a 1 by 10 array of 1s. The answer will times with a and x2 will use in plotting the magnitude. For C, the xn equal to exponential 2j pi n over n is defined. We will using a natural number which is less than 10 from 0 to 9. X3 will define as x3 equal to exponential in bracket 2j times pi times n over n. The answer will also use to times with a to get the x3, which is the DFT of the signals. The magnitude is plotting using stem, x label, y label, and title. For the result, we need to run it first. In the command window, we will get the answer for x is 111111111, and x2, the 10 at the first columns, and x3, the 10 will be at columns 2. For the graph, this is the DFT for the delta n with matrix. From 0 to 9, the value remains 1. For figure 2, which is the unity for the matrix, from 9 to 10, the stem height for 10 will only remain 10, while the others is zeros. For figure 3, the DFT of exponential j2 pi times n over n with matrix, we will get the answer. We will get a figure like this. The number of minus 1 are in the exponential because MATLAB indicates start at 1, not 0. That's all for me. Thank you.